In this example, we'll look at how to do a Verilog design using the Vivado Hlx 2016.2 version. So here's a very simple circuit consisting of AND, OR, and NOT gates. Inputs are A, B, C, D, and the output is Y. T1, T2, T3, T4 are names of internal wires, and U1, U2, U3, U4, and U5 are the names of the gates associated with this design. So let's look at how to describe this in Verilog using the Vivado Hlx software. So let's open that Vivado Hlx. When you open up Vivado Hlx, you come up with this interface. Now create a new project. So let's create a new project. Say hit next. I'll just give it a name, and I'm going to browse to my desktop. We'll call it Vivado 431. Select. And I will call it Project Verilog. Just the name that I gave it. Next, I want to create an RTL project. Next, I want to create a new file. So I'm going to say create file. And I will give this circuit a name. I'll call it my circ. Say OK. Just created this. Go next. I don't have any existing IP to add. I have no constraints to add at this time. I'm going to use the JET board. So select JET board and hit next. And I have created now a project. Okay. Now for my module name, so that will be the name of the circuit that I create, and I call it my circ. That's the name of the module. You feel free to modify this if you choose. First thing we want to do is describe the inputs and outputs. So here's the circuit that we want to build. This circuit has an output called Y and an inputs called A, B, C, D. The internal Verilog convention for built-in components is typically output is listed before the input. So that's what we'll do for our design as well. So output was called Y. Inputs are A, B, C, and D. Say OK. What this does is creates a skeleton module for my code. So here's the skeleton module for my code. Module name, output Y, input A, input B, C, and D. Now what I want to do is I'm going to slowly start describing this circuit. So I'm going to slowly start describing what I see here using Verilog. So let me expand that just a little bit, and I want to keep both the windows in view so that we can see as we describe. Okay. So the first gate, U1, that's an AND gate. So I'm going to use the AND. If it's built-in module, you see a purple color. The AND gate has a name, which we call U1. And all built-in modules have outputs listed before the inputs. So the output of this AND gate U1 is T1. So T1, comma. Now the inputs. A and B are the inputs. So A and B, close parentheses, semicolon. So we've described U1. Similarly, U2 is a NOT gate. So NOT is the name of the module. U2 is the name given to that module in this schematic that we have. The output of that module is T2 and the input is C. If you do this for U3, the output is called T3. It's an OR gate with an output of T3 and inputs of the wires T1 and T2. For this gate AND gate called U4, output is T4, the input is T3, and the system input D. And finally, for the final NOT gate right here, we have NOT U5. Output is a Y, and the input is a T4. Now, that is all we need to describe the circuit. A, B, C, and D were the inputs, and the output was a Y. Now we do have different internal wires called T1, T2, T3, T4, and T5. These need to be declared as internal wires for the system. So wire is a keyword in Verilog. So use wire, T1, T2, T3, and T4. So now we've declared internal wires and we've used those wires. So let's save this. I'm going to save this right here. And now I'm done with describing this circuit right here to here. So let's see if we can synthesize this properly. To do synthesis, on the left hand side on the project manager, go to run synthesis. And this will take the code we described and synthesize it to correct internal parameters. So this might take a little bit of time depending on how large the circuit is. Okay, the synthesis is now done. It came up with something called run implementation. Run synthesis takes our Verilog code and converts it into internal modules. During implementation phase, those internal modules were then mapped into the actual Hlx FPGA that we have. For this example, we'll skip that and just say open synthesize design, say OK. Just going to load the device and show me the internal design. So this module has been synthesized here, so it's hard to see what this is. So let's go up here. Under synthesize design, you should be able to see schematic. All right, so it took Hlx took the description that we had, A, B, C, and D, and output Y, and mapped it to what is known as a 4-input lookup table. Before it was able to do that though, so let's see how it translated this directly. So we can see that by going to RTL analysis and saying open elaborated design schematic. It'll say that you need to close the synthesis view, say OK. Right. So it's showing us the way we had described the circuit. So here's the AND gate. That bubble is a NOT gate. Here's the OR gate, another AND gate, and here's a NOT gate. So you notice that the structure of what this Verilog description got converted to, you can see it right here. Now when you synthesize it, this whole structure is mapped into internal components of the Hlx FPGA. The internal component of the Hlx FPGA is constructed with lookup tables. So the synthesized view, that's why, on the schematic of the synthesized view, you, instead of seeing individual gates, you see buffers. These are the input-output buffers, and here's your lookup table. So that's how you write Verilog and synthesize it for your particular design.